Imagine you're walking by a lake, and suddenly a snake jumps out at you, ready to attack. Now, imagine you hear the winning lottery numbers, and after the last number's read, you realize that you've won $50 million. Clearly, your reactions to these two scenarios will not be the same. But how can we see this in the brain? Over the past 10 weeks, I've worked towards helping to answer this question while learning a variety of useful skills and methods along the way. My name is Ron White, and I'm a biomedical engineering major with a minor in neuroscience at Penn State University. This summer, through SURF, I was fortunate enough to work under the leadership of Dr. Mingzhou Ding in the Department of Biomedical Engineering in the Herbert Wertheim College of Engineering. The project I worked on was entitled Analyzing Neuroimaging Data with Machine Learning Methods, which focused on analyzing fMRI data from an emotional imagery study. After exploring related literature in the field of affective neuroscience, I started my research with the question, what brain areas are activated by mental imagery of different affective scenes? I began by conducting a univariate analysis of fMRI data for 19 subjects to determine which brain regions showed greater activation when comparing 2 of 3 different emotion conditions, pleasant, unpleasant, and neutral. This analysis consisted of a first-level analysis and a group-level analysis, in which I generated contrast values between conditions and ran a voxel-wise statistical analysis to determine voxels with significant levels of activation. From this, I generated brain activation maps for each of the 3 condition comparisons, pleasant-neutral, unpleasant-neutral, and pleasant-unpleasant. To take this analysis one step further, I ran a multivariate pattern analysis using a support vector machine to determine if the activation in various regions throughout the brain had an above chance level of activation. I used numerous different regions of interest in this part of the analysis to determine if I could generate significant results that matched the findings of previous emotional mental imagery studies, which had not conducted MVPA. Interestingly, when I decoded the unpleasant neutral data using a region of interest mask based on brain activation map generated from the pleasant neutral data, an above chance level was shown, indicating that the regions that were activated by pleasant imagery were not exclusive to pleasant emotional processing. I noticed the same pattern with the unpleasant neutral mask and the pleasant neutral data. To try and reconcile this, I generated a weight map of each of these masks to determine the distribution of pleasant preferring voxels and unpleasant preferring voxels in each mask, in hopes to find that there were more pleasant preferring voxels in the pleasant neutral mask and more unpleasant preferring voxels in the unpleasant neutral mask. I'm still in the process of finishing this part of the analysis, but I'm hopeful that it will show the desired results once complete. This project has been an amazing learning experience for me, as it provided a first-hand introduction to affective neuroscience research and allowed me to learn useful tools and methods for cognitive neuroscience research as a whole. After graduating in May of 2024, I hope to apply these skills in graduate study in the field of neuroscience or neural engineering, and I'll be applying to the Biomedical Engineering Department in the Herbert Wertheim College of Engineering at the University of Florida for the fall of 2024, in the hopes to continue developing my skills in the field of cognitive neuroscience to prepare me for a career in cognitive neuroscience research. I would like to thank Dr. Ding and all of the lab members I've worked with for helping me learn how to apply machine learning to fMRI data analysis and guiding me along the way. I would also like to thank Mike Nazareth and Ashley Wilson for setting up and organizing an amazing program filled with memorable activities and helpful seminars, which allowed me to interact with like-minded individuals and enjoy my summer in Gainesville. Finally, I'd like to thank the University of Florida for funding the SURF program, as none of this would have been possible without their support. Go Gators!